Hello and welcome to my channel and my introduction on Matplotlib. In this video I'll introduce Matplotlib to you. So let's get right to it. What is Matplotlib? Matplotlib is essentially an object-oriented plotting library for Python and gives the user the capability to make plots as they would do in, for example, Matplotlib. Matplotlib comes with several modules, and the most commonly used module is the pyplot module, which can be imported for use using the following syntax: import matplotlib.pyplot as plt. This is mostly the way users import Matplotlib for use in their scripts or directly in the Python interpreter. Matplotlib can be used in Python scripts or directly in the Python interpreter, also in the IPython shell and Jupyter notebooks, or even web applications. To learn more about Matplotlib, you can go directly to the matplotlib.org. So basically, to plot in Matplotlib, you use the pyplot module, and the plotting syntax of Matplotlib is basically shown here. This star arcs and star quarks means that you can give multiple pairs of x and y's for your plot. So you can give, for example, x1 and y1, x2 and y2, and plot, and then you will get two lines with x1 against y1 and x2 against y2. So you can give multiple pairs of x and y's. Down here we have a more simplified version of the plotting syntax, of this plotting syntax. The first one shows that you can plot by just giving one pair of values. The first one will be the x, that's the horizontal axis. This one will be the horizontal axis, and this will be the vertical axis. If you give two pairs of values, the first one is the horizontal, the second is the vertical, and then you get a standard plot. Now this second syntax introduces a third argument, of which the first one, this b here, is the color of the line plot, and then the o here is marker of the plot. Now in this third syntax, a single set of values is passed, and that automatically becomes the vertical axis. So the values will be plotted against the vertical axis, and the horizontal will automatically become the number of points. Now in the final syntax, you can also customize the line plot by passing one set of values and then specifying the color, which is red, and the plus here gives the markers. Now that we have an idea of the syntaxes that we can use in Matplotlib, we'll go on to see some examples of graphs that we can generate using Matplotlib. So the first type is by giving one set of values, and by giving one set of values we can generate graphs of this nature. And by giving multiple set of values, that will give both the x and the y, we can generate graphs of this nature. Okay, so now let's go into the IDE and try to do some plotting. To begin the tutorial, we will need to import matplotlib.pyplot as plt, and we'll also need to import numpy. The first plotting example I would like to show you is a basic line plot. So I'll create an array a1. With these values I can plot already. That's how easy it is. Now to plot these values, all I need to do is plt.plot, and then I pass the a1 in. If I run this code now, the plot is generated, but it doesn't show it. So in Matplotlib, you always have to pass plt.show for the plot to appear. So if I run the code again, I get my line graph. You see the first value was 6, the next is 9, and then 11 and 14. It is also possible to plot multiple sets of data, and I will show this by creating a second list of figures. I've created a second data set, and I can plot the two together. If I plot these two now, it will appear on the same graph. We can see that the two sets of data are plotted on the same graph, and this is the first one and this is the second one. Now, after this introduction, I would like to show something a little bit more interesting. I'll comment out this. I'll call this single data set plotting. I will need some extra packages from NumPy, and to avoid writing np.np. all the time, I will just import those packages directly. So I will do this from NumPy import. I'll need pi, and I'll need linspace, and I'll need sign. Okay, so I create a new set of values. A1 is equals to linspace 0 4 pi, and then I want 100 points. You know that pi is 180 and 4 pi will be 720 degrees. So with these values I can directly do plt.plot, and then I will put this sign A3, and again I need to do plt.show to plot the sign of these values. So if I run this code, you'll see I have a sign plot. So this is possible in Matplotlib. Again, I could, if you notice, I gave the number of points I want. If you look in this graph, you will see that the number of points are 100, because 100 was specified here. If I take the 100 out, it's possible to take it out and run the plot, run the code, and we get this. So, and this time we have 50 points. So Matplotlib automatically, it picks some points for us automatically. So now that's possible. I would like to move on to multiple dataset plotting. So again, I'll comment this out. I'll comment this out and come here. I'll need this again. Now we can show the number of points again. We can immediately plot the A3 against the sign of A3. That's one pair of data. We can also give A3 again against the cos of A3, and I need to add the cos here. Okay, if we do plt.show and we run the code, we'll have two plots on one graph. And you know cos 0 is 1, so this is a cos and this is the sine, and this is the cos. So this is where this comes in, this syntax where that I talked about in the beginning. that you can give multiple pairs of x and y's, and that is what we have just shown in the previous plot by giving pairs of data, multiple pairs of data, and plotting them together in the same graph. So now you see that this is the first pair of data, and this is the second pair of data, and you can do it, it's multiple pairs of data, so as much as you like. There's no limit to this. I don't think there's a limit to that. So one pair, another pair, and so on and so forth. So you can give multiple pairs of data and plot them in the same graph, as we have shown in this plot. So to make this graph more clear, looking at this graph like this, it's because from your mathematics you can know that cos 0 is cos 0 is 1 and sine 0 is 0. You'll be able to know that this is the sine plot and this is the cos plot. But to make it a lot easier, we can label the plots, and that is very easy to do. All we need to do is plot them individually. So our path label is equals to cos A3, and then I would put it here again and call this sine A3. So after doing this, after labeling the plots, I have to call the legend. I have to call the legend, and of course I have to import so I'll just do it like this, plt.legend. I have to call this, and then when I run the code, the legend is now shown. You can see that the legend is now shown. So we see directly the blue one is the sine, and then the green one is the cos. Now we see that the legend is here, but if I do this, the legend is still there. Now if I play around with it, the legend is still there. The legend is at the top right, so whatever I do, the legend stays there. But sometimes you wouldn't want this to happen. If you want to actually use this for a paper, you wouldn't want the legend to appear like this. So you can give an extra command by specifying the location of the legend, and you can just tell Matplotlib to find the best location for the legend. So best, if we run the code again, we see that our plot in this case is here. If I do this, it changes the position, that it changes, it tries at every point in time to find the best location for the legend. And if I do this, it comes back there, it tries its best to find the best location for the legend. So there's an alternative way of showing the legend. Let me call that alternative legend. Let me take this, put it here, and then I'll comment this out. Okay, I'll come here. So now that I have this, I'll come to the legend, and then I'll create a list. So I have a list. So I'll pick this first label and put it in here, and then I'll pick the second label and then I put it here, and I can now remove this and remove this. And if I run the code, it should give me the same plot. It gives me the same plot, and the location also varies depending on the size of the plot. So this is also another way of plotting, but in this case you have to specify the labels in the order in which the plots are constructed. I know that the first plot is sine, so I put it first. The second is cos, I put it first. So this is, and in this, using this method, you really need to keep the order in which you are plotting your lines in mind to get the accurate plots, to know that what your plot, to know which line is which. You need to keep track of the order in which you are plotting the lines. For example, if you see here, we see clearly that the sine is the blue one and the cos is the green one, and it's because this order is given. If I change the order, for example, if I pick this and put it here, remember that the sine is blue and the cos is green. I close that and run this new one, and you see that the cos is blue, which is not correct. So it's because of the order in which they are specified here. The legend would be like that. So if you specify them wrongly, you get the wrong plot. So that's why I would advise that you use this approach, to define your legends. So because at every line you know which plot is which by defining it like this. So I recommend that you plot your graphs using this, or you label your plots using this approach, because you can't get it wrong. You see that it's sine, okay, the label is sine. You see that it's cos, okay, the label is cos, and it makes life easy. So that's that. We have everything correct. So this is where I would like to end my introduction to Matplotlib, and I believe that at this point you can plot line graphs and also name your plots. You can label your plots and find the best location for a legend. So thank you for watching, and if you like my video, please subscribe to my channel for more tutorials like this. And if you like the video as well, please give it a thumbs up by liking the video. Thank you.